On the morning of July 14th, 1933, a caisson worker stood at the bottom of a pneumatic working chamber sunk into the bed of the Mississippi River near New Orleans, 75 feet below the surface. Surrounded by compressed air at nearly 30 pounds per square inch above atmospheric pressure, the only thing keeping the river out. Below him lay 10,000 years of river-deposited clay and sand, soft the whole way down, with bearing material somewhere another 30 feet beneath his boots, according to the previous year's soil borings. His job was simple to describe and brutal to perform. Blast the sediment loose with a water jet, shovel it into a sealed mucklock for removal, and let the massive steel cylinder above him sink slowly under its own weight, and the concrete being poured on top, foot by foot, into the riverbed. He was one of roughly 40 men working compressed air that morning, in shifts limited by something doctors had only partially understood since the 1870s, and workers had understood in their own way since compressed air construction began in the 1860s. Come up too fast, and some men got very sick. Some died. The illness was called caisson disease. Everyone just called it the bends. This is the story of how Louisiana built the southernmost fixed crossing of the Mississippi River, at a point nearly a mile wide at flood stage, 100 feet deep in the navigation channel, with soft sediment extending another 50 feet below that before anything solid enough to build on. Engineers had called this crossing too expensive, too geologically uncertain, and possibly too far south on the river to found safely at all, for 30 straight years. It got built anyway in 3 years and 4 months, driven by a man who didn't believe things other people called impossible actually were. He was shot dead 3 months before the bridge opened. They named it after him. The lower Mississippi at New Orleans isn't the same river that leaves Minnesota. By the time it reaches Louisiana, it's collected the drainage of 31 states, cutting and abandoning channels across its floodplain for thousands of years, sitting on 200 feet of its own soft sediment before hitting anything resembling bedrock. At the proposed crossing, the channel ran 2,000 feet wide at low water, nearly a mile at flood, with surface currents reaching 5 miles an hour during spring runoff. And every foot of that current pushed against anything construction crews tried to sink into it. Below Memphis, no fixed bridge crossed the river at all until 1892, and every serious proposal for a crossing at New Orleans through the 1890s. 1900s and 1910s came back with the same verdict: technically possible, financially unworkable, foundation depths beyond anything the profession had achieved, navigation clearances pushing spans to the edge of what the era's engineering could economically manage, and traffic revenue nowhere close to covering the cost. The Southern Pacific Railroad kept ferrying its freight cars across one at a time, at the mercy of river fog that could shut the crossing down for hours. What finally changed in 1928 wasn't the river, or the engineering, or any new foundation technology. It was the election of Huey Long as governor of Louisiana at 35 years old, a man from the piney hills of North Louisiana who ran on roads, bridges, and schools funded by taxing the oil companies and corporate landholders who'd governed the state's resources for decades without much benefit to the people living on top of them. Between 1928 and 1932, Louisiana paved more road than it had in the previous decade combined. The Mississippi River Bridge was a different order of project entirely, the largest single public works undertaking the state had ever attempted, requiring the Southern Pacific's engineering capacity, a financing structure the bond market would actually accept, and engineers who genuinely understood what the lower Mississippi did to anything built in it. Long got all of it. The design went to Modjeski and Masters, whose principal Ralph Modjeski had designed more major American bridges than anyone of his generation. His firm spent months characterizing the actual river before designing anything, sounding depths, pulling soil cores, measuring current velocities, counting vessel traffic to determine required clearances. Their conclusion: the main channel needed 135 feet of clearance above high water, achievable with a cantilever truss design at a cost the financing could support. A suspension bridge couldn't hit that number affordably. The final design ran a continuous cantilever truss with a 790-foot main span, stretching 4.4 miles total including approaches, and every pier foundation required pneumatic caissons. There was no alternative the engineers could specify with any confidence, given the depth, the soft sediment, and the force of that current against anything else. If a story like this is worth your time, subscribing helps make sure more of them find their way to you. A pneumatic caisson is a method that works and a method that kills people. Compressed air holds back the water in the working chamber, while men excavate beneath the cutting edge. The whole cylinder sinks under its own weight as concrete gets added above. At 70 to 75 feet down, holding back that much water pressure meant roughly 30 pounds per square inch above atmospheric, enough to saturate a worker's blood with dissolved nitrogen proportional to pressure and time. Decompress slowly through proper staged stops, and that nitrogen comes back out through the lungs safely. Decompress too fast and it forms bubbles in the joints, the muscles, the spinal cord, the brain, anything from crippling joint pain to paralysis to death. Standard 1930s decompression protocols required 75 to 90 minutes of staged decompression after every shift, which meant actual working time in the chamber was constrained not just by how fast a man could dig, but by how long he could safely stay down before that decompression clock started. Caisson workers earned a wage premium above common labor, meaningful money in Depression-era Louisiana, where the alternatives for a black common laborer in Jefferson Parish were contracting cotton and sugar agricultural work, domestic labor at lower wages or nothing at all. Summer conditions at the Wagaman construction camp added their own misery. July river surface temperatures ran above 80 degrees, air temperature in the low to mid-90s, humidity that stayed brutal through the entire working day with no relief. And inside a compressed air chamber 70 feet down, the compressed air itself raised the temperature further, with zero cross-ventilation beyond whatever the machinery provided. A man came out of that chamber, passed through decompression, and emerged into July air on the riverbank that was only marginally cooler than what he'd just left. Above those foundations, iron workers from the American Bridge Company, a U.S. steel subsidiary, erected the truss steel, fabricated elsewhere and shipped in by rail and barge, working the cantilever arms outward from both main piers simultaneously while commercial river traffic kept moving beneath them on its own schedule, coordinated with the Army Corps of Engineers and the towboat operators who couldn't simply pause for construction. These crews worked at elevations from 70 feet above low water up past 130 feet at the peak of the main span, and the lower Mississippi produces its own November and December fog, warm river-meeting cooling air, capable of blanketing the entire crossing within an hour and leaving men navigating the upper chord of an unfinished truss purely by feel and memory of where they'd placed the last piece. A man who fell from that height went into water moving at 3 miles, an hour toward the Gulf, and whatever safety, boat was stationed below had only whatever response time the river and the current actually allowed. Records of deaths on this project were never fully compiled in any account. That's been made public. Louisiana's labor law documentation in the early 1930s was limited, and a man who went into the Mississippi from height and wasn't recovered, downstream might never have made it into any surviving fatality log a researcher could find decades later. Huey Long was shot in the Louisiana state capital on September 8, 1935, and died 2 days later at 42. By then, the bridge was substantially complete. Steel up, roadway finished, painting underway. He never crossed it. The legislature named it for him anyway. It opened on December 16, 1935, 97 days after his death, with speeches and a ribbon and photographs of highway commissioners and railroad officials at the East Bank approach. The men who'd spent 3 years driving caissons 85 feet below the riverbed and erecting steel 130 feet above the navigation channel were not there. The construction camp had already been cleared. The barges and equipment already towed off to the next job, because that's simply how this kind of workforce operates, following the work and disappearing the moment it ends. The bridge carried exactly the traffic it was built for from day one, Southern Pacific freight crossing in minutes instead of hours. No more waiting on ferry fog. Its automobile lanes were narrow by later standards, cantilevered off the sides of the rail truss within dimensional limits fixed in 1932, eventually restricted to vehicles under 8.5 feet wide, as cars simply grew beyond what the original design had ever anticipated. Not a structural failure, just a fixed dimension outliving the traffic environment it was built for. A parallel highway bridge finally opened incrementally in the 2000s to handle what the original crossing physically couldn't. The Huey P. Long Bridge is still in service today. The Southern Pacific itself is gone, absorbed into Union Pacific in 1996. But trains still cross on the same structure, over the same caisson foundations, sunk into the same sediment the caisson crews excavated by hand in 1933. At the midpoint of the main span, the river runs 90 feet deep in the scour hole below, current still moving at 3 miles an hour toward the Gulf exactly as it always has. The bearing material the caisson workers reached in compressed air 85 feet down hasn't moved. Neither have the foundations resting on it. Their names are in the payroll records of the Walsh Construction Company and the American Bridge Company, in whatever form those records have survived the 90 years since. They're not on the bridge. The bridge carries the name of a governor who forced it into existence against every piece of expert advice telling him it couldn't be done, and who never once got to drive across it himself.